Today we are going to talk about some of the ways that our planet has been shaped by natural forces, specifically in our corner of the map, the Pacific Northwest. Miles and miles of mind-blowing geological evidence are present that tell the story of how our land has been influenced throughout history by water erosion, fault lines, volcanoes, glaciers, and more.
We want to give a huge amount of credit to Nick Zentner, a Central Washington University professor who gave us permission to use his awesome footage of this most amazing subject matter. You wouldn't recognize this location by looking at the picture, but Nick is currently overlooking the city of Missoula, Montana. During the Ice Age, Missoula, and a lot of western Montana, was buried under an estimated 1,000 feet of water. The highest water line was above the M on the mountainside of modern-day Missoula at 4,200 feet of elevation. The Purcell Trench lobe of the eastern glacier blocked a mountain valley and caused the Clark Fork River to get backed up 200 miles east of the lobe. Glacial Lake Missoula spanned over 3,000 square miles. But the lobe of the glacier couldn't last forever. It is believed that the ice dam broke and allowed Lake Missoula to drain out at high speeds, probably many times throughout history. The amount of rhythmites, or repeating layers of mud and silt, seen on canyon and valley walls suggests that this high-speed flood could have happened up to or more than 40 times. Each time Lake Missoula rapidly drained, it would wreak havoc all along its path. J. Harlan Bretz is the geologist who dedicated his life's research to studying the features left behind by these Ice Age floods. He discovered objects that were dropped out of the suspended load of the flood into its deltaic plains, like this giant gravel bar, and these boulder fields, and these giant glacial erratics that don't match the biology of the land that they are sitting on. In the Camas Prairie of Montana, Joseph Pardee, a geologist, noticed these rolling hills. After attaining an aerial view, Pardee realized that these rolling hills were actually ripples caused by high-velocity water. The wild and powerful force of water also created vortices and started to bore holes into the earth below it. One of the amazing features created by these vortices is what is now called Dry Falls in Grand Coulee, Washington. This was once a wet waterfall that was 3.5 miles wide and flowed with 10 times the power of all the world's rivers combined. Just downstream of Grand Coulee, the vortices bore holes so deep that it created a chain of some of our present-day lakes. One lake in particular, at the end of this chain of Kolk lakes, or lakes that were caused by whirlpools, is called Soap Lake. Soap Lake was carved to be 70 feet deep and is a meromictic lake, meaning that the bottom half of the lake is made up of different minerals and different densities of minerals than the top half, and the two halves never mix. People have flocked to Soap Lake for many years and sought healing from its unique makeup of minerals. The black, deep-water mud of the east bank of Soap Lake has been used to treat ailments like psoriasis, lumbago, bunions, and even Berger disease and Raynaud's disease. It's awe-inspiring to ponder, what other wondrous anomalies have we discovered solely due to natural disasters? And how much more unknown anomalies are hiding under the Earth's surface?
In the middle of southern Oregon, sitting within the Cascades, is an unusual lake. A lake that was created with what they call the grew, blew, fell, and fill process. This lake is called Crater Lake. Crater Lake was formed from a volcano known as Mount Mazama. Mount Mazama was created by pressure from magma pushing on the Earth's crust, creating a bubble-like mountain that was ready to erupt. The pressure from underneath the surface finally broke and released the magma. After the magma was released from the crust, over time it left the volcano drained with only a little at the bottom. The volcano collapsed on itself as all that was left was an empty shell. The collapsed volcano left a bowl-shaped caldera in the Cascades. For years the caldera filled with rain and snow. It took 250 years for the rain and snow to form the lake we see today. The Rocky Mountains stumped geologists for years. The confusion was on how this 2,000-mile-long mountain range could be formed so far from the tectonic fault lines. Even the base of these massive mountains is 220 meters above sea level. So how were these mysterious mountains formed? The clue was found in the rock found within the mountain. The Rockies are made up of ancient granite rock, only found deep within the Earth's crust. Scientists call this rock the basement rock because of its location in the Earth's crust. This brought evidence of a formation of what scientists call the thrust up. What is the thrust up? Basically, 1,000 miles from the start of the Rockies is a Pacific Ocean convergent plate. The plate is sliding underneath the crust because of the convection cells within the mantle dragging it. The plate is traveling under the crust at a point that we call a trench. Normally, this plate would go deep into the mantle and melt, and later come out of ridges as new crust. Instead, this plate is floating and pushing up against the crust. This caused the crust to be thrusted up by the plate, forming the Rockies. When you think of the largest canyon in the U.S., you probably think of the Grand Canyon in Arizona. Though the Grand Canyon is the longest canyon, Idaho has a record canyon as well. Idaho has the deepest canyon in the U.S. This canyon is called Hell's Canyon, located in the Seven Devils mountain range. It plunges 2,436 meters at its steepest point and is 125 miles long. It was formed by a couple of geological factors. Underwater volcanoes built up the land while tectonic plates assembled the mountains. The final piece was the Snake River flowing in between, carving its way in the mountains and picking up and moving material on its way. This whole process was said to take 6 million years to get what we see today.
All of this geological information is just the tip of the iceberg. Much, much more goes into the story of how the ground beneath our feet has been shaped, both uniformly over time and sporadically all at once.